All right, guys, we are going to do, I know this is like another 3.3a. Why is there two 3.3a's, you ask? Because Ms. Jones messed up on the alphabet. So we're just going to keep rolling because that's what my lesson plans say. And that's what my notes say. So we're just going to keep going with the fact that I made two A's. Okay. So 3.3a, polynomial functions. The first 3.3a was in behavior. The second one is polynomial functions. Don't make it bigger. Big deal. Okay, guys, just roll with it. All right. So we're going to just, after we've talked about in behavior, we're going to kind of work a little bit backwards, okay? Making sure we understand what a polynomial function is, okay? A polynomial function is a sum of power functions. So basically, a polynomial function is me adding and subtracting a bunch of terms together. Does that make sense? That's all it is me adding and subtracting a bunch of terms together, okay? You have been working with polynomial functions all along, okay? So for example, a polynomial functions of different degrees we've already been working with since beginning of algebra, okay? A degree, a 0 degree power function, all that is a constant, which is just a number, right? A first degree polynomial function, that's just a linear equation. A second degree polynomial function, that's just a quadratic. Okay, have we not worked with constants, linears, and quadratics? We have. So you've been working with polynomials all along. They just weren't really called polynomials, okay? What makes something a polynomial is that in any term, the degree is greater than or equal to 0. Okay, that's it. So you can't have a negative, you can't have half of a power, you can't have any of those, you can't have a variable in the denominator. Otherwise, it's not a polynomial, okay? We're going to be dealing with a couple new degrees. So we're going to be dealing with a third degree. A third degree is called anyone knows? A cubic. And fourth degree. That is going to be generally the highest we go in Algebra 2. And fourth degree. Anyone want to take a stab at what that's called?
No. No, not quad. Didn't have that.
Almost. Quartic.
So is fifth degree
a fifth degree polynomial? What is that right part? I don't think it is. It's a quintic.
But hit means fine. So does quin.
So does quin.
Yeah,
quintic.
But hit sounds better.
It's quintic, hectic, heptic, octic, nonic, dectic. Something like that. Like dectic? Like a decade? For 10 degree? All right, so here we go. We're going to practice identifying whether things are polynomials or not, okay? If it is, we're going to say what the degree is, okay? And how many terms. Terms are how many things are being added and or subtracted, right? All right, number one. Is it a polynomial?
No.
Yes. Yes, it is. How do I know? All of my exponents are greater than or equal to 0, correct? And I have nothing, no irrationals, nothing in the denominator, no square roots, no half powers. So this is a yes. Okay, now we're going to name it. What kind of polynomial is this? It's a fourth degree or a quartic. Does it make sense? How do I know? Because what is my highest power? 4. So I can write fourth degree or I can write quartic. And the terms, how many things are being added or subtracted together? 3. So this is a 3 term, fourth degree or quartic polynomial. Okay. Number 2, is it a polynomial? No. It's a 3 term because I'm adding and subtracting 3 things.
Oh, okay.
Your terms should be a word from when you're adding and subtracting, okay? Why is this a no? Who caused the problem? The square root, this guy right here, okay? All right, 3, is it a polynomial?
No.
Why is it not?
Because there's a negative.
There's a negative power. Okay,
Wait, so if it's a negative power, it can't be.
no,
Right,
you're,
it gotta be a whole
it has to
number.
be greater than or equal to 0.
Wait, but where's the negative and that little thing right there? Like even if it's up there, it can't be.
Yeah, you can't have a negative exponent.
What if it was a negative like 3?
It doesn't matter.
Like if it was negative 3x.
Yes, your coefficient can be negative, your power can't be negative.
Okay.
Okay, all right, 4.
No, because there's the,
It's where? It's in the denominator. Okay, what about 5?
no.
5 is a yes.
Oh,
The variable's in the numerator. I can have numbers in the denominator, but I can't have the variable. Yes, it's a first degree, aka linear.
Why is it? Okay.
Okay, why is it a first degree? Because even though I can't see it, Casper the friendly one is there, right? So it's a first degree polynomial, and how many terms are there? 2 terms. Okay, 6.
Oh, because of that.
Big fat no. All right, 7. Yes. Okay, 7. So in order to figure out its degree, we're going to go through and we're going to expand it, right? We're going to do a little math. So this means we have 5. My pen is doing weird things. Let's try that again. 5x times x minus 3 times x minus 3. Okay, how you distribute is up to you. I personally like to just distribute from left to right. If you like to do your binomials first, you more than likely can, but it really doesn't matter. Does this order of multiplication matter?
No.
No. 3 times 2 is the same thing as 2 times 3 all day, every day, right? So from left to right, I'm just going to distribute. I have 5x times x is 5x squared. 5x times negative 3 is negative 15x. So that's my first distribution. Now I'm going to continue to distribute. 5x squared times x is 5x cubed. 5x squared times negative 3 is negative 15x squared. There we go. Negative 5x times x squared is negative 15x squared. Negative 15x times negative 3. I can zoom in if you can't see.
45.
That's going to give me 45x. Can you see now?
Oh, gosh, yeah.
Okay.
No, not really. Positive.
A negative times a negative is a positive. So when I'm all said and done, I have 5x cubed minus 30x squared plus 45x.
And then.
So what kind of polynomial is this?
It's a third degree
A third degree.
with third term.
So it's 3 terms, aka a trinomial.
Right.
So it's a cubic, and you either can write 3 terms, you can write trinomial, doesn't really matter. That all means the
Same.
same. 3 terms is the same thing as writing trinomial.
Wait, so it's third degree,
Why is it third degree?
there's 3 terms and it's cubed.
It's the 3 makes it third degree, right? That's what makes it a cubic. Okay?
So even if there wasn't a 0 there, it's
No,
things with X to do with that,
it would still be a trinomial, but not a cube. Okay?
You only need to like simplify it if it's got like a parenthesis in it.
Yes. Parentheses is my sign that I need to distribute.
Like, so what if it has 2 terms?
Then it's a binomial or 2 terms.
So it doesn't matter what we write, we can say trinomial or 3 terms.
Yep, as long as you know they're the same.
So for our answer, we'll just say yes, it's degree and how many.
They said they couldn't see.
It's messing with my eyes.
They said they couldn't see. I want to make sure we all can see. All right, 8. Is it a polynomial?
Yes.
No. Why?
Oh, because there's an X up at the top.
The variable is the power. That's called an exponential. Remember, we had a whole unit on that.
I thought.
Okay. All right. How do you feel about identifying a polynomial and stating the number of terms? Okay. Just to recap, I think I didn't say this very well, but I'm gonna say it now. If I have 1 term, that's called a monomial. If I have two terms, that's called a binomial. And if I have three terms, it's called a trinomial.
Hold up, miss.
Okay, everything else is just the number of terms. They're the only three that have special names.
I gotta do it.
Okay, does that make sense? So if I have more than three terms, I just have 4 terms, 5 terms, 6 terms, okay? It's just a polynomial.
And how would you simplify?
Mono,
Mono,
bi.
and tri.
Yeah.
Okay.
mono is 1, bi is 2, tri is 3. Okay,
And she should be funny, I'm paying attention.
thank you. All right. Okay, next, we're gonna talk about determining the roots of a polynomial, okay? When a polynomial is in factored form, how many factors you have is the number of roots, okay? Shh, guys. So determining the degree and the roots of each polynomial. So the first thing is, in factored form, number of factors equals number of roots.
Is that like the number of parentheses?
The number of parentheses, or, well, in this case, it doesn't have parentheses, and that's still a factor, So looking at number 9, how many factors do I have? 2. So there are 2 factors. So therefore, my degree is second degree. Does that make sense? I have 2 factors. So the degree is second. The factors, guys, we just did a whole unit on factors. Your factors are the things that multiply to expand out. So I'm multiplying x minus 2 times x plus 3. That is 2 factors,
So
right?
if there was 3, it would be the third degree one.
Yes.
Okay. Oh, okay.
All right. So this is a second degree polynomial. Does that make sense?
Mhm.
Okay. Your roots, to find the roots, we talked about this before. You just set each factor equal to 0. So if this equals 0 and this equals 0, what would x have to be?
0.
No. -2. And what would this have to be? Well, +2 and -3. Because what would make the factors equal to 0? 2 minus 2 equals 0. -3 plus 3 equals 0. Those are your roots. That's where you're gonna cross the x-axis at,
Oh, so we just do the opposite within.
for the most part.
So we're just trying to make them equal 0.
Yes. All right, so let's try it again. So here, this was a little tricky.
Is it 3 factors?
Exactly. So in this case, that square actually means that this is x times x minus 4 times x minus 4, right? How many factors do I have? 3. I have 3 factors. So what is my degree?
Third degree.
It's a third degree. Do we see that? Okay.
Oh, this is pretty easy.
So then after that, what are my roots? Well, this is x equals 0, and these two are gonna be the same. So does it matter which one I do? And x minus 4 equals 0. So x equals 0. And what would x make x? +4.
+4 squared.
Just need one. We're gonna talk about it a little more, what it means to be squared. Okay, yes, are we okay? All right, 11. So even though I only see one factor, how many really are there? There are 3 of them. Do we see? There's no variable there, so that's not a fact. It's not a variable factor. Okay. So we have -x minus 2. Shh, guys. Okay, how many factor terms do I have? Okay, in order to be a factor term, there has to be a variable there. And there's only 1, 2, 3. So there are 3 factors, which means that this is a third degree polynomial.
So would it be x equals 2?
And the only one that I can write is x equals 2.
Oh, look at that. I'm learning a little song.
Okay, all right, let's make sure we get this. So on here, how many actual x's are there?
2.
There's 2 of these. There's negative x and another x,
So
right?
it's 4.
There we go. X minus 4 and x minus 4. How many factors do I have?
4.
4. So there are 4 factors, which means that this is a 4th degree.
I'm so smart. Look at me.
Okay? So x equals what? 0 and x equals 4.
Do we have to put the x equals 0?
Yes, you have to put x equals 0 because it is a factor. All
I
right?
was like, because I'm thinking like, okay, if you just put the 4, then the x is not really there, you know?
I got you. But yes, you do. All right. So how?
So right.
All right, guys, please, you should still be seated. We have 3 minutes. So I want to talk to you about your assignment. And thus far, you should be able to roughly do the front page of your assignment. Okay? Being that we've talked about in behavior, and we've now, huh? I can't, what? Oh, yeah, because she came 5 minutes late. Yeah. I don't know what to tell you. I don't know. I repeat, I don't know what to tell you. All right. So whenever it opens, I'm going to show you. Okay, here we go. So you should be able to do the front side. Now, why wait last minute to do it if you don't have to? Okay, well, that's a, whoa, why is it zooming in so much? Okay, all right, so 1 through 9, you're going through and you're telling me, what we did, like, is it a polynomial? If so, what is the degree, the number of terms, okay? On the bottom part, 10 through 15, you are finding ones that match the end behavior. And then, going from there, so matching the end behavior to the graph, got it? Yes, no, maybe so?
Yeah.
All right. And then we'll talk about other factors because you may not be able to do all of 10 through 15 without the rest of our notes. But you should be able to do the beginning.